Hey everyone, welcome back to my YouTube channel. So today is day 32 of solving daily LeetCode challenges. Let us see what today's challenge is. So the problem says that you're given the head of a single linked list. The list is represented in this form and we have to reorder the list in the following form. So as you can see that how we are performing this operation, that the first node and then the last node, then the second node of the linked list, then the second last node of the linked list. In this order we have to rearrange our linked list. Okay, so here example 1 is given. You can see the linked list is 1, 2, 3, 4. And after performing the operation, the linked list has become 1, 4, 2, 3. So it has this order now. So this will be our answer 1, 4, 2, 3, and we have to return it in the we have to perform all the operations in our original linked list only. We need not to create a new linked list or use any extra space here. Okay, so let us try to understand this with the help of example. So here you can see that this is example 1, which is given already given there, and you have seen this. Now I have 3 pointers which are head, which are fast, slow and previous. Okay, all are pointing to my head of linked list. This is my head. This is the head of linked list and all the 3 pointers are pointing to the head. Then now to arrange my linked list in that particular order, what I will do is I will first use these 2 pointers. Okay, so I will make slow point to middle of my linked list. Let's say if slow is on head, slow is present on head, fast is also on head, and I will run a for loop to check for fast not equals to null and fast next not equals to null. So here its next will be null. In first case, my fast pointer is not null. So what I will do is I will move fast pointer 2 points ahead. Fast will be equals to next ka next. So simply my fast goes to here. Okay. And after this, my slow pointer is moved from here to second node. Okay. Now I will again check if my fast next equals to null. It is not equals to null, but fast next will be null. So in this case, we will not perform any operation and I can say that my fast, okay, fast next is not equals to null. So I can move it from fast next to next, which will make my fast null. So in that case, I need not to perform any operation. I will simply be here. It will here store the address of the next pointer, which will be this only. Okay, so fast is storing the address of this pointer and slow is pointing to 2 in this case. Now with the help of reverse function, I will reverse this particular part of my linked list. Okay, now after reversing this, it becomes 4 and 3 in my linked list, in my original linked list only. So the list becomes 1, 2 and 4 and 3. Now I have a pointer slow, which is pointing to the which is pointing to this node, and a fast pointer which is pointing to this node. So with the help of a merge function, I will merge these two linked lists. Okay, so inside this merge function, I will pass the two nodes which will be L1 and L2. L2, maybe L2 is equals to reverse of slow. So the node which will be returned from the function L2, my L2 will be equals to, let's say, reverse of my linked list, and here I have to pass the slow pointer because it is pointing to this node. So from here our a new pointer will be returned which will become L2, and let's say this is L2 and this will point to L1. L1 is equals to head of the linked list. L1 is pointing to the head of linked list. Okay, L1 is pointing to head. Now simply what I have to do is I have to merge these arrays. So I will take first node from here 1, and after that I will take second node from L2 and I will move L2 to L2 ka next, and I will move L1 to L1 ka next. Simply after 4 I will take this node from L1, I will make it 2, and then I will take a node from L2 which will 3, and this is the answer I need, or this is the order I need to arrange my linked list in. Okay, so similarly in this example also we will first initialize 3 pointers which will be slow, fast and previous. Okay, these 3 pointers are here. Then let's say it is slow, fast and previous. Okay, so previous is pointing to the previous node of my linked list, and while reversing I will return the previous node. Okay, so let's say agar if we have slow fast pointer here, then I will check fast ka next not equals to null, then I will move my slow pointer from here to here, and I will move my fast pointer from here to here. Okay, now again it will check fast ka next not equals to null, fast not equals to null, so it will move my fast pointer to this node and it will be here, and my slow pointer from here to here. Okay, so my slow will come to third middle pointer. Slow will be at the middle of linked list. And similarly, same operations we have to perform. We have to reverse this part of linked list. So now it will become 5. 5 will point to 4. 4 will point to 3, and the rest of the linked list is same. And after that, this point will be L2 and L1 will be present here at the first node, and then one by one we will take the nodes. So 1 from L1, then second node will be 5 from L2, then third node will be from L1 which will become 2, then next node from L2 which is 4, then the last node of L1 will be 3, 1 2 3, and here we can say that our linked list is reversed in the order we need. Okay, so now let's try to code this problem. In this problem we have to create two functions. Okay, other than this we will create two functions. First function will be to reverse my linked list from that particular part, from central node, from center of the linked list, and second will be for merging the linked list. First here I will check if my head equals to null ptr, or my head ka next equals to null ptr. In this case I have to simply return the return head. Okay, otherwise I will declare 3 more pointers here, node list node star, and we will give it a name of slow which will be equals to head. Similarly I will declare 2 more pointers here. Okay, one, I will name it as fast which is also equals to head, and a variable previous which is also equals to head. After that I will run a while loop to check if fast, while fast not equals to null ptr, and fast ka next not equals to null ptr. Okay, inside this loop I have to move my slow equals to slow ka next, because I'm moving slow 1 pointer ahead and I'm moving fast 2 pointers ahead. Okay, fast equals to fast ka next. Okay, and this is we have done, and let us also store our slow in previous. Now this part is done, and now what I will do is I will say previous ka next equals to null. Okay, let's say slow is 1 point ahead and previous will be here only, so I will make previous ka next equals to null. Previous here in this case previous will be, and previous ka next we will break this link between 1 and 2, and wherever my previous node is, let's say if previous at first position, so it is pointing to second position, I'll break this link by this line. Okay, then previous ka next we have initialized as null. Then what we have decided that we will create another two nodes, list node star L1 which will point to head of my linked list, L1 equals to head, and another list node star which will point to the head of reversed part. Okay, we can say it that it is pointing to head of reverse part. So in reverse I have to pass my slow pointer. So here it is done, and after that we'll create a merge function to merge both the linked list, where we will pass L1 and L2. Okay, so now let me define here the first function which we are using is to reverse the linked list, and I have previously made a video on this also, to how to reverse linked list. And here I will get a list node star as my pointer. Let's say it is L2. Then we will here create a node star to point the current node cur equals to L2, and a previous which will point initially to null. Okay, null PTR. And after that I will run a while loop to move in my linked list and change all the pointers cur equal not equals to null PTR. Inside this, we will create a list node star, which will point to the next node of my linked list next, which will be equals to karka next. And now I have to reverse the pointer, so I will make it karka next to point to previous, and previous I will move to the current node, and now current equals to next node. Okay, so here we have written the code to reverse our linked list, and from here we have to return the previous variable, previous pointer. Okay, so this part is done. Now we will create another function void, which will be merge, which is having two nodes at as its parameters L2, and after that we have to simply merge this array. So while let me check L2 not equals to null PTR, and now what I will do is I will again create a next pointer which will point to the next node of L1, and L1 ka next. Now I will make L1 ka next point to my L2, then I will make L1 equals to L2, and now L2 which will become equals to next. Okay, so this we have done with the help of two other functions, reverse and merge. Now let us try to run this code. It says error, should not return a value. Okay, we need not to define here, we can simply make it, if it's equals to null, head is equals to null, we need not to return head from here, we will just return. So it is accepted, and now let's just submit this to check for other test cases. We have successfully completed today's challenge, and I hope this video is clear to you, that the way I have explained and the approach I have used. So please like on this video, comment on it, subscribe to my channel, press the bell icon to get daily notification about the videos I'm posting. Thanks for watching, and I will see you in the next video.